Hi folks. So on my last video where I took the garden hose and I kind of flushed out my Toto Drake toilet bowl, I mentioned something called Venturi action, and somebody on that video wanted to know more about how that works. So there's other places that you can research this on the internet, and you can find, if you search Venturi or Venturi pumps, you'll find diagrams and other things that'll help explain how they work. But I'll make some drawings to attempt to explain how it works as I understand it. So basically, what a venturi is it's like a jet. So if you can envision, say, a pipe, I hope that shows up on camera, and then you make a little, you kind of constrict the end a little bit, and then if you pump water or air, but let's say water, out of that pipe at high pressure, you'll have a high pressure jet of water coming out, if that makes sense. Now, if I, let's say this was my garden hose. If I take my garden hose and spray a strong jet of water out into the air, what actually happens is, because there's a high pressure stream of water coming out of the end of this pipe, in this area right here, it actually generates an area of low pressure in the area right around where the jet starts. And because that's an area of low pressure, in this case air would come in, it would be drawn to that area of low pressure, and the action of the high pressure jet would have a tendency to suck air in from behind and want to blow it out alongside the jet, if that makes sense. So if I held my hand out in front of the jet, not only would I feel water coming out of my garden hose, but I would feel air. I would feel air drafting this way, being blown this way because of that jet action. And so that's kind of what happens, like even if you just had a jet of water or even air. If you have an air compressor and you blow a high pressure stream of air out into the atmosphere, that's what'll happen, is it'll have like a blowing effect. So to take this to another step, there are pumping devices called a Venturi pump or a jet pump, and what that would look like basically is, you have a jet of water. Well, you have some kind of a jet here, and then how should I draw this? Okay, here's what my crude drawing of a Venturi pump looks like. You've got high pressure air or water, and these things work above, they work in the air. They also work just the same underwater, but you've got high pressure, let's say air, let's say water, being pushed in the pipe up to this small jet hole, and then what you're going to have is a high pressure jet of water. This is another pipe, okay? Typically what a Venturi pump would look like is you have a jet pointing into a funnel or a cone, and then it blows into a pipe that is bigger in diameter. This pipe is bigger in diameter than the jet pipe. And then you've got a third pipe in here. This is an open pipe. And so remember, there's low pressure generated in these areas, this area surrounding the jet. With this jet stream pointing up the pipe, you're going to get suction in this pipe. That's backwards. You're going to get suction in this pipe, and this jet is going to want to pull air or water up that pipe, that discharge pipe. So you know, it's basically like a vacuuming device. And this is solid here. This is just a solid wall. And so you've got jet water streaming up inside this pipe, and it's sucking fluid or air from this pipe going up with it. And so what's coming up here is a combination of jet water and water from the inlet pipe, I guess you'd call it, you know. And so let me draw something else now. Okay, so I've got a kind of primitive toilet bowl drawn now. And you can see here we've got a bowl. There's the trapway. Here's a siphon jet right here. This is an opening. And so if this, let's say this jet, or this area here is pressure fed, either from a flushometer or even from just a gravity tank, it is under pressure. If you force a jet of water out the siphon jet hole and squirt it up the trapway, you can understand from the previous drawing how in this area right here you'll get that suction effect, you'll get that low pressure. And so anything, you know, water in the trapway will be sucked up the trapway and out, just because you've placed the jet right in the trapway so that you take advantage of that suction effect. And that is basically how a blowout toilet works. And that's really the difference between siphoning action and blowout action. Is, you know, many toilets have a jet here of some kind, and you can do one concept, which is to, you know, run a stream of water out here and just use it to shoot, you know, to fill up a siphonic trapway and get a siphon started, and then siphon the bowl to a flush. But you can also, typically if this jet is under a bit higher pressure, if the jet gets to be so strong that it just you know, sucks the bowl out, then you're not really working on siphon action anymore. It's turning more into a blowout toilet. And those differences also play into the difference between your siphon jet trapways and a blowout trapway. I drew a blowout trapway here because if you're relying totally on jet action to clear the bowl, then you want as few bends in the trapway as possible. And also, ideally, it's probably not very pronounced, but ideally, in a blowout toilet, the smallest part of the trapway is right here at the mouth of the Trapway. Ideally, it should get a little bit bigger as you go down, because back to this drawing, you know, high pressure out here going into your discharge pipe, your large discharge pipe here. Having this funnel shape in it helps aid the jet action. It helps draw things in through the suction pipe and up through. It creates like a pressure differential there. That's the best I can explain it. And so, you know, that's one characteristic of a blowout toilet, is you want it to be as straight as possible. And ideally, if anything, it should be either one diameter all the way through, or it should even get a little bigger. But in a siphon jet toilet, you want the opposite. You know, in a siphon jet toilet, usually somewhere down at the bottom you'd have a restriction, so that the trapway can fill up with water and you can purge air from the trapway so that a siphon can start. So that's pretty interesting. Hopefully that helps explain more of the principles involved in how a blowout toilet works. And that is Venturi action as I understand it. And I hope you found this helpful and interesting. And again, if you are interested to learn more about this, you can look up Venturi pumps on the internet, and you'll see more things like this. And I hope you enjoyed. Thanks for watching. I'll see you later.